Okay, today we're going to talk about exponents, laws of exponents. You need to remember those from the beginning of the year. And we'll kind of review it a little bit. Graphing exponential functions, we'll go over that whenever you have a base of e. That part's something new. Okay, so we're going to go over all that today. So the notes are going to take a little while. We definitely need to review laws of exponents, make sure we're all on the same page, and then graphing. Okay, so the very first part is negative exponents. Whenever you have a negative exponent, what happens is it flips. It does the reciprocal. So if it's on the top, it'll flip to the bottom. If it's on the bottom, it'll flip to the top. Okay. And it says that does not indicate that you're going to have a negative number. And everybody thinks that. If I have a negative exponent, it's going to give me a negative number. And that is not it at all. It just means that it's flipped. Okay? So on number 1, we have 5 to the negative 4 power times 5 to the 3rd power. So this negative exponent on the first term flips it. So we have 5 to the 3rd over 5 to the 4th. Now, with whenever you're dividing numbers with exponents, if they have the same base, what you can do is just subtract your exponents. And that's one of the laws we learned at the beginning of the year. So 3 minus 4 would be negative 1. Okay, we have another negative exponent, which means it's going to flip. And my answer is going to be 5 to the 1st power, or just 1 over 5. So it flips to the bottom, becomes 1 over 5 to the 1st power, which is 1 over 5. Okay. So we're just going to review some laws of exponents real quick. We have 2 to the negative 3rd squared. Okay, so if you have a power to a power, the rule is that you multiply those two exponents. Okay, power to a power, you multiply. So 2 to the negative 6th. If you have a negative exponent, it flips. So 1 over 2 to the 6th power. And 2 to the 6th power, we can go ahead and figure that out. It's going to give you 1 over 64. All right, so let's try the next one, number 3. We have 8 to the 3rd times 8 to the 5th, all over 8 to the 9th. Okay, now since they all have the same base, on the numerator, you're multiplying. So a little review, whenever you multiply the same base, you add your exponents. So this should be 8 to the 8th power on top. If you add 3 plus 5, you get 8. On the bottom, you have 8 to the 9th power. Okay. Whenever you're dividing, you subtract your exponents. So 8 minus 9 would give you negative 1. And a negative exponent will flip. So my final answer would be 1 over 8. So let's keep reviewing number 4. We have 5/6, and all of that to the negative 3rd. Okay, there's a couple different ways you can do this. You can distribute that negative 3 power to both of them. So you get 5 to the negative 3rd over 6 to the negative 3rd. Okay. The negative exponent on both of them is going to flip it. So my 5 will move to the bottom and my 6 will move to the top. They're just going to flip. So I get 6 cubed over 5 cubed. And you can figure out what 6 cubed is in your calculator. 6 cubed is 216 and 5 cubed is 125. So that would be my answer. The other way you could do it is you can say, okay, I have a negative exponent for this whole fraction. The negative is going to flip it. So if you want to go ahead and flip it in the beginning, you could, and you would still end up with the same answer. You would get 6 cubed over 5 cubed, which is 216 over 125. So there's a couple of different ways you can do it, but just make sure you follow your laws of exponents. Okay, the next page. All right, let's look at number 5. On number 5, we have 5x to the 4th power y cubed over 8x to the 5th times 3x cubed y to the 5th over 6y to the 4th. Okay, so we're multiplying. Whenever you multiply fractions, you multiply across. So I'm going to multiply my numerators together, and then I'm going to multiply my denominators together and get one big fraction. Okay, so 5 times 3 for your coefficients would be 15. When I multiply my x's, when you multiply, you add your exponents. So 4 plus 3 is 7. On my y's, I have y cubed times y to the 5th. That's going to give me y to the 8th. So that's my numerator. 15 x to the 7th, y to the 8th. The denominator, 8 times 6 is 48. My x won't multiply with anything on the denominator, so it's going to say x to the 5th. And my y, there's not another y, so it'll say y to the 4th. So now I have one big fraction. All right, now we can divide. So this fraction, 15 over 48, will reduce. So you can put it in your calculator if you're not sure what it reduces to. 15 divided by 48, press math and enter. You should get 5/16. Okay, and then my x's, I have x to the 7th divided by x to the 5th. I'm going to subtract those exponents, and I get 7 minus 5 is 2. Okay, I'm going to leave everything in the numerator with these exponents until I get a negative exponent. Then I'll flip it at the end. But always make sure you keep it in the numerator until the very end. If you get a negative exponent, you'll flip it. Okay, so on the y's, I have y to the 8th divided by y to the 4th. So subtract your exponents. 8 minus 4 is 4. Okay, and I can't reduce that anymore. I don't have any negative exponents, so I'm done. All right, I'm gonna let y'all try 6 and 7 real quick, and then we'll check. It does need to be pretty quick because there's quite a few notes on here. So go ahead and try those, and then we'll check. So on 6, when you multiply across, you should have gotten 8x to the 8th, y to the 7th. The denominator, you should have gotten 72x cubed, y to the 5th. Okay, so we're multiplying across. Whenever you divide and simplify this fraction, 8 divided by 72 will give you 1/9. Whenever you divide your x's, you should have gotten x to the 5th, y squared. Okay. And you don't have to have that 1 in front of the x. It could be a sneaky 1. So x to the 5th, y squared over 9 is what you're probably going to see, like if you had a multiple choice answer. They wouldn't show the 1. All right, the next one, what I like to do on things that look kind of complicated like this with the negative exponents is I like to save my negative exponents for last. I won't flip until the very end. Because a lot of times your negative exponents will go away whenever you multiply or you divide or something like that. So I don't flip until the very last step, usually. So on the top, if I multiply my x's, I'm going to add my exponents. So -2 plus +2, those will cancel. And that's what I was kind of talking about. Some of these will cancel, or you'll end up with a positive exponent. And if you flipped it, you wouldn't see that. It might make it more complicated. Okay, on my y's, if I add my exponents on my y's in the numerator, I get y squared. And my z's, -1 plus a +1 in the numerator, those will cancel. So I only have y squared in the numerator now. Okay, the denominator, I don't have another x, I don't have another y, I don't have another z, so I'm going to put, they're all going to stay the same. X to the -3rd, y squared, z cubed. Okay, next step, I'm going to divide. So on my y's, I have y squared divided by y squared. 2 minus 2 is 0. Those are going to cancel. Okay, so I'm going to have x to the -3rd, z cubed in the denominator. And since I don't have anything in the numerator, I just put a 1. Okay, now my last step, I'm going to start flipping my negative exponents. So my x to the -3rd will flip and move to the top. So it'll be x cubed over z cubed.